Hello, welcome back. Okay, so in the last series of videos, we were doing a whole bunch of stuff with z-scores and sort of what they mean and how to interpret z-scores. Essentially, z-scores just tell us how far away some value is away from the mean in standard deviations. Okay, so in this set of videos, I'm going to try to keep it quick as far as this first set, because I want to get into some examples quickly, just so you're prepared for the test. But we're going to be talking a bit more about what else you can do with z-scores. That should be fairly intuitive since we know the formula as is. Okay, so let's get into it. What can we do with z-scores? Well, we've been doing this. We've been finding the z-score pretty much all the time, right? That's all we did in the last video, series of videos. But we also have two other things we can do with z-scores. We can find the probability of that z-score, which then we can interpret back into the original units. We can find that probability of that thing occurring, right? So whatever we measure, we're able to say that, okay, well, getting at least that z-score, or getting at most that z-score is some probability, right? So that's easy enough. If you've taken stats before, and I think I mentioned this somewhere in the last series of videos, but if you've taken stats before in high school or in college or just wherever, oftentimes z-scores, finding the probability from a z-score can be very sort of complicated because you have to use a table, which is not, and they're not easy to use. We're going to totally skip that, and we're going to use the internet and a calculator to figure it out because it's 2020, and I don't want to. Using those tables is the most antiquated method of finding probability. We're not going to worry about it, right? We can get a better estimation with a calculator. So I'll send you that link, or you should already have that link to the website that we'll be using for that. So that's going to be easy enough. Then also. We can find the raw score, and all the raw score really means is the original score, right? So in the first case where we were finding the z-score, we're given something, and we want to figure out how far away it is from the mean, right? Finding the raw score, it's just the opposite, right? So we're given a z-score first, and all we need to do is work that equation around to find x instead of z. Okay, so we'll just move on real quick. So probabilities, going to the second thing, the second idea of z-scores, finding probabilities takes about 7 steps, but three of them we've already done. So that's fine enough. 2 of them are just drawing. One of them requires the internet, and it pretty much does it for you, which is great. And then 7 is just sort of the conclusion there. Now, I mentioned this at the end of the video on the last slide. You don't have to do these. Each 7 steps. I will show you how how you can do it in these 7 steps. But this is more or less just to help you keep things organized, because there's a lot of bits and pieces that can get lost. And it's very important that you keep track of them at least somehow. And I think that this is the best way of doing it. But if you feel like you can skip around on some steps, that's fine. Just make sure that you are keeping track of everything. So, like I said, the first 3 are stuff we've already done, right? So we're looking at 1 here. 1 is just defining the mean and the standard deviation. I chose to use x bar and s here, but you could easily substitute mu and sigma, all right, for the population side of things. Whatever the context is, the process is still the same. Okay, we're just using different symbols here. Okay, and then step 2 is just writing the probability statement, which is essentially just restating what is written in the question. So if the question is, if you're looking at heights of people in the U.S. and you want to know what's the probability that somebody is at most 5'1", right? So all the values from 0 up until 5.1, what's the probability of selecting somebody in that range? Well, you would just write it a little bit shorter as this. Okay, so P, all P stands for is probability, and then you replace X here with whatever thing you're measuring. In this case, maybe height. And then you would just say, is it greater than or is it less than? What's the probability of that value being? And then you would just fill in whatever it says in the question. So that's easy enough, right? That's just an extra step to something that we're already kind of used to seeing. And of course, you'll be given these to make things easier. All right, and then all you need to do is convert whatever thing you're measuring, convert it into a z-score based on whatever was found here or whatever was given here, and just restate it, right? So instead of saying x is less than 5'1" or height is less than 5'1", then you would say, okay, whatever that z-score is for 5'1", you would just substitute in here. And then you would just leave z. Z is z, right? It's unitless. Okay. 4 and 5, we've done a little bit of sketching, but it always kind of helps to see what sort of area you're working in, because sometimes, and I'll kind of give you an example here. Sometimes you might be given a distribution, a normal distribution, a standard normal. Actually, I won't draw that middle bit. All right, easy enough. And so you might be asked, like, what's the probability of getting something that is at most, whatever this value is? Well, then it would just help to shade in, and it'll make sense when we're looking at the online tool, the online calculator. You want to make sure that what you have shaded in and what you've understood in the question is also being reflected in step 6 here, which is done online, and it actually draws a picture for you as well. But you want to make sure that you're entering everything in correctly, because you will get different values if you don't. Okay. Sometimes I might ask a question. Oh man, dang it. I might ask a question. Looks like this. Whatever. Maybe I ask something. What's the probability of getting any of the values in between these two things, right? And so you would shade in this area, and then it's a little bit easier to work with once you get to the calculator. Okay. So that's easy enough. I'll show you. I promise I'll show you here in just a second. It's not too complicated. At least I know. You probably hate me saying that. I don't think it's complicated, but I've been doing it for a while. It might be a little complicated at first, but once you get into the groove of things, I promise it makes much more sense the more practice you get. Okay, and then at the end, whatever probability you find, you just say, the probability of height. Yeah, I guess we're over here. The probability of height being less than 5'1" is whatever the value you got, whatever the value was from step 6. And the process looks like it's drawn out, but it's really not too bad, I promise. I know I flew through that. So what I'm going to do at the end, I'll pause the video and we'll go through some examples just to kind of show you what I'm talking about. Okay. Whoops. And then going on to the other side of things, finding the raw score or the original score, whatever it is, heights, weights, GPAs, whatever. Sometimes you'll be asked to find a z-score for that, so how far away it is from the mean. If you were to move around this equation, you can get it to where you can find the raw score or the original units, where you're given all of these, and all you need to do is a little bit of algebra, right? So I would recommend writing this down and putting it on like a formula sheet if you've had one. Of course, you've got this too. You can easily move this around with a little bit of algebraic manipulation, fancy word for just saying moving some stuff around. But you can get this fairly easily. Okay, so here are some types of Z problems. I've just kind of gone over them. And in fact, these are not my slides. These are like department slides. I'm doing things a little differently. Ignore this and ignore this. But the idea here is what I've been kind of saying ad infinitum, is that, well, if you're looking for the z-score, all you need to do is that equation, and you stop there, and that's it. Finding probability, you first find the z, shade the area, and then use the calculator online. And then finding the raw score is just the opposite of this, right? So you're sort of undoing the z-score. So that's easy enough, and you're probably, hopefully you're not lost. But if you are, I'm going to work through some examples at the end here, just so you can kind of see, because this is a big deal, and I really want to make sure that we're all on the same page and not having too hard of a time. Okay, so some last kind of closing notes on this section, because this is going to be it until the test. So actually, I guess before I'll talk about the test, everything that we've learned up until now will be on the test, and hopefully you're not watching this. Hopefully you're not watching this, and the test is an hour from now. Hopefully you've gotten enough practice. If you haven't gotten enough practice, then I would throw together a formula sheet and hope for the best there. But I intend to have a sort of even amount of questions from each section each week here. And it will be more so if you've seen the study guide and seen the homework 3 that's not graded, then that's what's going to be the test will be very similar to that. And you won't get any curveballs or anything like that. So it's not going to be too bad. It's going to be an even mix, I think, of everything. A shorter amount of questions, but within the questions we'll have a little bit of everything. So just kind of keeping that in mind. Anyway, more info on that, in an announcement somewhere. You can see that I'm recording these in advance, so I'm not. I can't really tell the future, but that's my intention at least. Okay. Anyway, some additional things about probability that are important. The first thing is that I kind of go between using less than or greater than or I should say, less than or equal to and greater than or equal to. In probability, it's the same. It's the same thing. There's like a big explanation that kind of utilizes calculus. We don't need that. We don't even we're not even close to needing that in this class. So don't worry about it. So all I'm saying here, the take home is you can use either, and it's fine. It means the same thing. So that's kind of nice. Okay, and then sort of a sub rule of this one is this one. The probability of a single value, of a single continuous value occurring is almost zero. It's not totally zero, but it's so tiny that we just round it down to zero, and that's that. Again, sort of the explanation is a component of the explanation in this. Doesn't really matter. So do keep an eye out for this one. So the probability of a single continuous value occurring is 0. It's almost 0. So that's all right. That's why we work in this sort of. I'll draw it out again. Oops, come on. That's why we work in like this kind of situation where it asks, what's the probability of this value and all the values below it, right? Because you can imagine that if we wanted to get even closer, this is going to be a smaller area, get even closer, so that's going to be an even smaller area, and then, we can get infinitely close to this value here, but that area is going to be so tiny that it's like inconsequential. It doesn't actually, it's pretty much 0, right? So that's why we work in the at least, at most, and between kind of scenarios. And then I mentioned it before when we were looking at the 7 steps, but that 7-step process for finding that probability, it's only there to help you organize things. You'll see me when we go into, I guess, a couple of questions in. I'll start to skip some steps and kind of streamline things, but still, it's all organization. So it really is just making sure that you've got everything in order and making sure that it's not, you're not missing any steps. So that's that. I'll pause. Oh no, actually one last thing. So sorry. I mentioned in the last video that if we have a z-score that's above 3 or less than -3, that's considered an outlier. Sometimes you'll hear if it's above 2 or less than -2, then it's maybe an outlier as well. That kind of varies between person to person, which is weird, I think. So I'm just going to lay it out like this. So if, and I've got a picture on the other screen, or on the other slide too, but if a z-score is between -1 and 1, it's normal, it's expected, right? Sort of going in that it makes up 60%, 68% of the distribution is between -1 and 1 on a standard normal, or on a z distribution, same thing. So -1 to 1, totally expected, right? It makes sense that the data point or data points lie within that range. And then once you get between -3 and -2, or 2 and 3, right? So that sort of range of values, those are unexpected, but it's not of any concern, right? Moderately unexpected, but not totally out there, right? It's when you get here, below -3 standard deviations away from the mean, or above 3 standard deviations away from the mean, then that's an outlier. That's a big time. That's because there's only like 1% of, let's see, let me do some math here, less than 1% of the data that should fall out there. It's odd if you have a data point that falls out there. Now it's fine because outliers are still, totally real and not any concern, more or less, because they do still tell quite a bit of the story. It tells you a good bit about your distribution, but trying to keep things technical and kind of standardized, we still consider a data point that falls out of that range as an outlier. And here's a picture, sort of saying the same thing, right? So we have this range here, this range here in yellow, that totally expected, not a big deal. As you go further out, so we have these kind of like light green, light blue shaded areas. Still fine. That's an area of unconcern. We don't need to worry about anything out here, and out here. But as you go a little further out, this area here, if any data points fall out there, it's unusual, but it's not a big deal. It's not a big deal. It's not until you get way out here to where it's like, okay, what happened? Was there a data entry error, or is it like actual data? So that's when you would just go back and check. And if it is genuine data, sweet, that's fine. You got more of a story to tell. If it's a entry error, then whatever, you would go out and fix that, and then maybe this would change just a little bit. Okay, so I'm pausing the video, and we'll work on some examples here in just a second. So I'll see you then.